So, what exactly is lactose intolerance? It's the body's inability to digest lactose, a disaccharide found in many dairy products that we consume on a daily basis, such as milk, cheese, cream cheese, among many others. It's caused by a deficiency of lactase enzymes, which are produced in the small intestine. A person can have low lactase levels but still be able to digest dairy products without any serious issues. But when lactose intolerance is present, lactase levels are extremely low or sometimes non existent. When lactose is ingested, gastrointestinal symptoms will occur. Lactose intolerance does not, however, cause damage to the gastrointestinal tract. The breakdown of lactose. In a person without lactose intolerance, lactase enzymes in the small intestine work to divide lactose into two simple sugars, glucose and galactose. These are the two monosaccharides that make up the disaccharide lactose. They are then absorbed into the bloodstream through the villi in the small intestine. We can use the enzyme substrate complex to show how lactose is broken down by lactase in the small intestine. Lactose intolerant people with little to no lactase enzymes are unable to break down the lactose, thus making it impossible to absorb in the small intestine. The lactose goes into the colon, where it interacts with the normal bacteria in the large intestine. This interaction leads to uncomfortable gastrointestinal symptoms that characterize lactose intolerance. This image shows lactose tolerant people versus lactose intolerant people. Symptoms of lactose intolerance include diarrhea, nausea and/or vomiting, abdominal cramps ranging from mild to very severe, bloating, excess gas, and the symptoms typically start 30 minutes to 2 hours after eating or drinking lactose products, although it can take longer or even shorter for certain people. There are three types of lactose intolerance, the first being primary lactose intolerance. It's the most common type to occur, and it's only present in adults. The lactase enzymes are present at birth since infants need breast milk or formula or milk for nutrition. When they get to an age where solid food is introduced, they gradually replace milk with food for further nutrition. The lactase enzymes naturally decrease into adulthood, and most adults have enough to digest lactose properly. But for those with primary type, lactase production sharply decreases. Primary type is genetically determined and is caused by the absence of the lactase persistence allele. The LCT gene provides instructions for making lactase and is turned on or off by the MC-M6 gene. These two genes are located on the long arm of chromosome 2 in region 21, which would be the 2q21. Some humans developed a mutation of the MC-M6 gene some several thousand years ago, which keeps the LCT gene turned on after stopping breastfeeding. The mutation is not present in those with lactose intolerance. Primary type can also be linked to certain heritages. Approximately 75% of African Americans, Native Americans, and Jewish Americans are lactose intolerant, as are 90% of Asian Americans and 53% of Mexican Americans. Analysis of the DNA of 94 ancient skeletons from Europe and Russia show that the mutation for lactose tolerance appeared about 4,300 years ago, and this mutation spread throughout the European population, which then led to some populations having developed lactase persistence, which is when lactase production continues into adulthood, probably as a response to the benefits of being able to digest milk from farm animals. Secondary type is caused by an injury to the small intestine, not by genetics. It can occur at any age, even in adults who are technically lactase persistent. This type can be reversible if the underlying cause is treated. It can be caused by celiac disease, Crohn's disease, ulcerative colitis, chemotherapy, intestinal parasites, acute gastroenteritis, among many others. Reversal of secondary type can take years, and some people are unable to reverse it. The last type is congenital lactose intolerance. It's very rare. It's an autosomal recessive enzyme defect that prevents production of lactase. It's present at birth, making breast milk indigestible for newborn babies. For a child to have this type, both the mother and father must pass on the gene variant. Premature babies are more likely to have a type of lactose intolerance called developmental lactase deficiency. It's usually grouped under the congenital type. The condition does not typically last long, enabling them the ability to drink breast milk when they are finished developing. There are many ways to diagnose lactose intolerance, but the most common and the most accurate way is by using the hydrogen breath test. Hydrogen is the product of undigested lactose fermenting in the colon. So if hydrogen is detected by the breathalyzer, then the person is positive for lactose intolerance. This test is not performed on babies and children because of the high risk of severe diarrhea. Two other tests that are not as commonly used are the blood test and the stool acidity test. The blood test is not used much anymore because it's been replaced by the easier, more accurate hydrogen breath test, and it's also very time consuming. But for infants and children, a stool sample is taken to test for acidity. So if the acid levels are high, then the child is lactose intolerant. Since we live in a society that loves all things dairy, the market for pills containing lactase enzymes is pretty large. Lactate is the most well-known lactase supplement, and it claims to help symptoms associated with lactose intolerance, including gas, bloating, and diarrhea. But like most things, it doesn't help for everyone. See, lactose intolerance is very individual. Some people are more tolerant of milk, some people are more tolerant of cheese, some people are less tolerant of milk and cheese. It just depends on the person. So it's all just a matter of trial and error if this would be a solution for lactose intolerance.